We can complete our overview of normal cardiac anatomy by looking at the conduction system. Now, if I show you this posterior aspect of a normal heart that I've demonstrated so that you can see the atrial chambers, the ventricular chambers, and here the origin of the aorta from the left ventricular cavity, you can see why we need a conduction system. And that is because the atrial myocardial mass, the right atrium, the left atrium, is separated here at the atrioventricular junction and is insulated from the ventricular muscle mass. So somehow we need a special set of myocytes that generate and then conduct the cardiac impulse, passing it across this area of insulation between the atrial myocardium and the ventricular myocardium. Now, we can't see the specialized myocytes that form the conduction system and distinguish them with the naked eye from the atrial or the ventricular myocardium, so we need landmarks to tell us where we find the components of the conduction system: sinus node, the atrioventricular node, and the atrioventricular conduction axis. The sinus node is found in this area, where the superior cable vein takes origin from the right atrium. The landmark to the sinus node is found here relative to this large muscle bundle, which is the terminal crest or the crista terminalis. Now, the terminal crest is an internal muscle bundle, and on the outside that marks the area of the terminal groove. And here I've cut away the right atrial appendage, but the right atrial appendage has a crest where it joins the superior cable vein. And we find the sinus node here lying in the terminal groove, in most instances just inferior to this crest of the right atrial appendage. And so we find the sinus node lying immediately subepicardial here within the terminal groove. And in the adult heart, it's about 1 centimeter in length. It's a cigar-shaped structure, and importantly, it is immediately subepicardial. In 1/10 of individuals, the node extends like a horseshoe across this cavo-atrial junction. And importantly, in this particular specimen, where I've dissected away the anterior intraatrial wall, you can see how the terminal groove becomes directly continuous with the intraatrial groove, so that the sinus node can not only pass its impulse down along the major bundle of the terminal groove, but also can pass in front of the orifice of the superior cable vein so as to activate the left atrium through this anterosuperior margin of the atrial chamber, Bachmann's bundle. Now, the sinus impulse having activated the atrial myocardium, the impulse passes through the ordinary atrial myocytes until it reaches the apex of the triangle of Koch. Now, you will remember that I showed you how the triangle of Koch is formed between the tendon of Todaro, the attachment of the tendon of Todaro into the central fibrous body, and the hinge of the tricuspid valve. Now, in this specimen where I've cut away the aortic root, we can see the central fibrous body, because the central fibrous body is this area here where the right fibrous trigone becomes continuous with the atrioventricular component of the membranous septum. And having made this dissection, I can show you how the right atrial surface of the triangle of Koch, with here the coronary sinus forming the base of the triangle, is directly adjacent on the left ventricular aspect to the crest of the ventricular septum. So the atrioventricular node, positioned here at the apex of the triangle of Koch, has only to penetrate through this area of the central fibrous body to reach the crest of the ventricular septum. My dissection here shows you very nicely the attachment of the septal leaflet of the tricuspid valve, and it is the septal leaflet of the tricuspid valve that divides this membranous septum into an atrioventricular component and an interventricular component. Here the interventricular component is barely formed, but very nicely here you can see this small area of musculature which is the bundle of His. And once it has penetrated and reached the crest of the ventricular septum, the bundle of His branches into a right bundle branch and into a left bundle branch. If I return now to one of my intact hearts, I can show you the relationship of these structures rather better. Because now in my intact heart, I can show you that by putting tension on the eustachian valve, I bring into prominence that tendon of Todaro. So here is the tendon of Todaro, and we see very beautifully in this heart how it inserts into the atrioventricular component of the membranous septum. We can also very nicely now see the triangle of Koch, formed by the tendon of Todaro, the hinge line of the septal leaflet of the tricuspid valve, with the orifice of the coronary sinus at the base of the triangle. So here at the apex of the triangle we find the atrioventricular node. The conduction bundle penetrates through the membranous septum, and here very nicely we see the tricuspid valve dividing the membranous septum into an atrioventricular part and an interventricular part, and then the bundle passes to reach the left ventricular outflow tract. So having reached the left ventricular outflow tract, the bundle branches. The left bundle branches pass down the smooth left ventricular aspect with an anterior fascicle, a middle fascicle, and a posterior fascicle, and then the bundle itself passes back through the ventricular septum, penetrating through the musculature to emerge here beneath the anterior papillary, the medial papillary muscle, and then descends through the substance of the septomarginal trabeculation, crossing the cavity of the right ventricle on the right bundle branch. So to find the presence of the atrioventricular conduction axis, we take the apex of the triangle of Koch, we take a line from there to the medial papillary muscle, and that line marks the position of the atrioventricular conduction axis. Then within the right ventricle, the right bundle then runs down as a narrow cord towards the anterior papillary muscle. Within the left ventricle, the left bundle branches cascade down immediately subendocardially on the surface, the smooth left ventricular septal surface.